forgets that I have my money, and this is our project for the SD. My name is Islam Osama, and I'm the team representative. When we thought about the problem to solve, we chose two of the major problems that we face here in Egypt. The first is electricity, and the second is traffic jams.
To solve the two problems, first we're going to handle the problem of electricity. Whenever a street is empty out of cars or people, we don't need the street lights to be turned on. So we simply turn them off whenever there are no cars in the streets. And for the problem of the traffic, instead of having a traffic man at each intersection, we simply handle the problem using automated timers for traffic lights. So simply the side of the street which have more cars, its timer will have longer time. So the large number of cars does not have to wait the same time as the other side of the street which has fewer cars.
To model the idea of the traffic intersection, here we have a street with two counters and a traffic light. This counter counts the number of cars coming in, and this counter counts the number of cars coming out of the street. On the other hand, we have another street with the same exact two counters and their traffic lights. Here we have an indicator for the street lights that only turns off when there is cars passing by. Like this example here, it turns off. It turns on the light, and whenever the car goes, it turns off. This screen here demonstrates the number of cars passing through this street. Here, 1, 2, and whenever the cars goes away, it goes back. The counter goes back to 1, and again to 0. Same thing for the same street, and the light alternates according to the counter right here that counts the time according to the number of cars. Since the number of cars is 0, 0, the counter is 0, 0. But whenever we add some cars, the time is calculated according to the number of cars standing in the traffic light.
Okay, regarding the hardware part, we are having here in the circuit 4 infrared sensors, 2 for each road. Here are the sensors for this road, and every sensor is connected to the power and having the common ground. The common ground is connected to the board, and for the power is connected to the 3.3 volts of the input for the board. And concerning the output from the board, it's connected to the input for the LED. Those LEDs connected to the output from the board as shown here, and every LED is connected to 2 series 100 ohm resistor.
I've implemented 3 modules in the project. The first one is the clock, the timer, and the control. The clock takes as input the 50 MHz clock from the Altera board and delays it to 1 Hz. Then the timer takes as input the 1 Hz clock, the 2 counters of the 2 roads, and outputs the time. The time depends on the count of each road. For each car in the road, we specify 5 seconds. So we multiply the count of the cars by 5. Then there is the flag that is outputted from the timer and decides which road is open now. The flag and the 2 counts are inserted in the control. The control controls the traffic lights and alternates them, and it also controls the street light. When there are no cars, meaning the 2 counts are 0, the control turns off the street lights. When there are cars, the street lights are turned on. Then the control also controls the 4 LEDs according to the flag that it receives from the timer.
Based on the clock module we discussed earlier, we implemented another module. This module is considered the main or the biggest module so far, as it does all the work behind the scenes. The first part of the module is the incrementer. It listens to the positive edge of the clock as well as the inputs from each of the sensors, and based on which sensor is being cut, it decides whether to increment or not. The values are hard-coded into a switch statement to make this process easier, and in order for the code itself to not be confusing to the machine or to anyone who's reading it. So whenever the sensor is being cut, it goes into the switch statement, checks that it's in the increment state, and then finally increments the variable that we consider a counter.
Leading on what Hadi has said regarding the sensor responsible for incrementing the count, I have implemented another sensor for decrementing the count. So this is in the same always block which listens to the incrementer. It also listens for the decrementer sensor. So it's sensitive to the positive edge of the clock, and whenever there is a change in the input, so it listens to the input, and if the input of the sensor responsible for the decrementing the count is 1, then it has to decrement the count. This sensor resembles the cars moving out of the street, so we decrement their count. So it starts decrementing the count of the cars of the street in the streets, so that if there are 5, there will be 4, and so they are hard-coded that whenever it detects 1 in this sensor, it decrements the count 5 to 4 and to 3 accordingly, and so on.
To alter the idea that Hadi and Mark implemented to be able to display it on 2 7-segment displays, we had to present each number as unit and tens. Divide the number into 2 digits. One represents the unit and one represents the tens. First of all, as Hadi explained, the unit keeps incrementing until it reaches 9, and whenever it reaches 9, we have to increment the 10th unit and set the unit with back to 0. This is what I implemented in the incrementation part. In the second part, to decrement, we have to go to the unit part. We have to go all the way from 9 to 0, and whenever it hits a 0, it turns back to 9 and sets the 10th part to -1. That's it.
Module acts as the connector that connects all the other modules together. It takes as an input the inputs from the 4 sensors, the incrementer sensor and the decrementer sensor in each road in the intersection. In the sensor module, these pass by the signals, which tells us if a car passed by, to the counter module. The counter module counts which car, how many cars are in each road, and then it passes by these information to the timer module. It uses the count of each road to calculate the time of each lane, the time that each road will wait, and then the timer module will pass by its outputs to the control module to alter the LEDs.
First of all, we're going to show this LED here that imitates the street lights that turns on and off according to if there's any cars or there's no cars present in this intersection. If we consider this Egyptian parrot as one car, whenever one car passes by, the counter turns to 1 and the street lights is on. Whenever this car leaves the intersection, the counter turns back to 0 and the street lights is back to off.
Now we are representing the solution for the traffic jam part. So whenever a car enters the street, it's counted here as 1 car, and then when a second car enters, it's 2 cars here, and so on, so it's 3. And whenever a car enters the other side, so counts it as 1 here. When another car enters, so it's 3 cars on this side and 2 cars on this side. So, and whenever a car goes out of this side, now we have 2 cars and only 1 car on this side and 2 cars on this side. And now the lights are green for this side, and there are 2 cars on the other side. So when it switches, then the counter started from 10 and it's going down, because we are simulating 5 seconds and giving 5 seconds for each car in the side. And now it will turn to 5 seconds because there's one car only on this side. So, and it goes on.